An asphalt highway cuts through a flat stand of red pine and glacial gravel in southern Ontario. Drivers pass over at 90 kilometers per hour, seeing only drainage ditches and uniform fences. Beneath the topsoil sits a geological anomaly larger than the Niagara Peninsula. For over a century, surveyors mapped the surface without realizing the underlying strata were warped by forces hundreds of meters below. How did a continent-spanning structural system remain obscured beneath ordinary farmland? Before answering that, this investigation examines a drowned valley in the St. Lawrence, where entire main streets sit beneath 15 meters of fresh water, and a subterranean salt sheet in the Gulf of St. Lawrence, whose vertical pillars rise higher than the CN Tower. Fact 50. The Goderich Salt Deposit beneath Lake Huron. Directly beneath Lake Huron at Goderich, Ontario, lies one of the largest salt formations on Earth. The Salina Formation sits 530 meters down, originating from a Silurian sea that evaporated 400 million years ago. Miners from Compass Minerals harvest rock salt from vast rooms cut into the seabed. The salt bed extends beneath the lake floor, forming a solid mineral pillar supporting millions of tons of overlying rock. The Geological Survey of Canada confirmed the layer continues into the Michigan Basin, anchoring southwestern Ontario's industrial geology. Fact 49. The Barrier of Barrier Lake. In British Columbia, a natural dam formed by geological instability created Barrier Lake. 12,000 years ago, a collapse along the volcanic face of Mount Price released 30 million cubic meters of rock into Rubble Creek Valley. The resulting stone wall, the barrier, blocked meltwater behind a cliff of fractured dacite. Water seeps through the porous rubble rather than flowing over the lip. Provincial engineers evaluated the site in the 1970s, declaring the area below unsafe for human settlement due to risk of failure. Fact 48. The Long Point Peninsula. Extending 40 kilometers into Lake Erie, the Long Point Sandspit represents a complex coastal structure. Formed by longshore currents depositing glacial sand, this narrow peninsula contains 9 ecosystem types within a single landform. Freshwater marshes, dunes, savannas, and hardwood swamps sit side by side. Designated a UNESCO World Biosphere Reserve, Long Point serves as a critical stopover for 300 species of migratory birds. The Canadian Wildlife Service manages the area, preserving a landscape where northern coniferous plants meet southern Carolinian forest. Fact 47. The Algonquin Axis. Deep beneath southwestern Ontario lies the Algonquin Arch, a subterranean ridge of Precambrian basement rock. Spanning hundreds of kilometers, it separates the Appalachian Basin from the Michigan Basin. Tectonic forces bowed limestone and shale layers upward, creating traps that accumulated Canada's earliest commercial oil and gas reserves. The arch's elevation prevented deep burial of organic sediments, maintaining optimal conditions for hydrocarbon preservation. Mid-19th century geologists discovered this bulge governed every major oil field in Lambton and Middlesex counties. Fact 46. The Niagara Escarpment. The topography of southern Ontario is defined by the cliff faces of the Niagara Escarpment. Formed 400 million years ago, this landform owes its survival to the Lockport Formation, a hard, silty dolomite caprock. As ancient rivers and glacial ice eroded softer underlying shales, the durable dolomite resisted weathering, leaving vertical cliffs stretching 720 kilometers from New York State to Manitoulin Island. The escarpment dictates drainage, creates dozens of waterfalls, and forms a microclimate supporting the Niagara Fruit Belt. Fact 45. The Oak Ridges Moraine. Running parallel to Lake Ontario, the Oak Ridges Moraine covers 1,200 square kilometers. Formed 13,000 years ago between two converging ice lobes, it consists of permeable sand and gravel reaching depths of 200 meters. This geological structure acts as a freshwater sponge, capturing rainfall to feed 65 streams flowing into Lake Simcoe and Lake Ontario. Natural Resources Canada hydrogeologists demonstrated this aquifer provides drinking water for 250,000 residents while maintaining stream flows during droughts. Fact 44. The McMurray Formation bitumen sands. Beneath northeastern Alberta lies the Athabasca oil sands, the largest natural bitumen deposit on Earth. The McMurray Formation consists of early Cretaceous deltaic sandstones deposited by rivers emptying into the Boreal Sea. Over millions of years, crude oil filled the porous sand, where microorganisms stripped lighter hydrocarbons, leaving a dense bitumen matrix. Covering 140,000 square kilometers, the formation holds an estimated 170 billion barrels of recoverable oil, requiring thermal and surface extraction. Fact 43. Merbleu Bog. On Ottawa's eastern boundary sits Merbleu, a 3,500-hectare boreal peat bog persisting for 8,000 years. Originating as a channel of the Champlain Sea, the basin filled with waterlogged sphagnum moss that prevents organic material from fully decaying. The peat created a raised, highly acidic bog environment with scarce nutrients. Specialized flora like pitcher plants and sundews evolved to trap insects for nitrogen. Environment and Climate Change Canada monitors the site as a critical carbon sink, maintaining unique hydrology within a suburban region. Fact 42. The submerged St. Lawrence Seaway communities. In July 1958, flooding for the St. Lawrence Seaway submerged 9 historic communities in eastern Ontario, known as the Lost Villages. Construction of the Moses Saunders Power Dam created Lake St. Lawrence, inundating 200 square kilometers of land. 6,500 residents were relocated to towns like Long Sault before waters rose. Today, beneath 15 meters of water, concrete foundations, sections of Highway 2 and sidewalk grids remain visible. The flooded valley altered the shoreline, turning an agricultural corridor into a shipping channel. Fact 41. The Crow's Nest Formation volcanic agglomerate. In southwestern Alberta, the Crow's Nest Formation exposes an explosive Cretaceous volcanic deposit embedded within sedimentary rock. Formed 100 million years ago, it consists of ash, tuff, and rare analcime-bearing phonolite lava ejected from volcanic vents. The resulting rock features pink sanidine crystals and green pyroxene minerals in a fine matrix. Geological Survey of Canada geologists identified the formation as a rare place where mid-Cretaceous volcanism disrupted mountain-building sedimentation. Fact 40. The Luther Marsh Peat Mat. Located in Wellington and Dufferin counties, the Luther Marsh Conservation Area protects an expanse of floating organic soil. Beneath shallow open water sits a thick layer of unanchored peat moss, creating quaking earth. When walking onto specific sections, shock waves ripple across the ground as the mat floats above liquid mud. The waterlogged basin prevents decay, trapping thousands of tons of carbon. Grand River Conservation Authority monitoring confirms this wetland regulates downstream flood flows across the watershed during spring rains. Fact 39. The Dunvegan Formation petrified wood. Along the Peace River Valley in northwestern Alberta, sandstones of the Dunvegan Formation hold fossilized ancient forests. 95 million years ago, a delta emptied into the western interior seaway, depositing mud and ash over fallen trees. Oxygen was cut off, allowing silica-rich groundwater to replace plant cells. Royal Tyrrell Museum paleontologists recovered petrified logs with vascular rings, confirming subtropical cypress and ginkgo forests flourished across northern Alberta long before the Rocky Mountains rose. Fact 38. The Horn River Basin Shales. Buried 2,000 meters beneath northeastern British Columbia lies the Horn River Basin, a shale formation holding massive natural gas reserves. Deposited during the Middle Devonian, organic-rich black shale originated as marine mud in a stagnant ocean basin. Trapped beneath impermeable limestone, Subterranean pressure and heat converted decaying plankton into natural gas held in microscopic pores. Geoscience BC mapped the formation across 12,000 square kilometers, determining directional drilling could unlock a major unconventional gas reservoir. Fact 37. The Queenston Formation red clay. Running along the base of the Niagara Escarpment through Halton and Peel regional municipalities, the Queenston Formation forms a belt of red soil. Deposited 440 million years ago, this mudstone unit received iron-rich sediment from the eroding tectonic mountains. As sediment oxidized in shallow mudflats, it turned into hematite-rich red clay. The Ontario Geological Survey notes early brickworks in Brampton and Mississauga utilized this clay to build much of Toronto's 19th century architectural infrastructure. Fact 36. The Oak Ridges Moraine Glacial Divide. Bisecting the landscape north of Lake Ontario, the highest crests of the Oak Ridges Moraine rise 300 meters above sea level. Formed during the late Wisconsin glaciation, the Simcoe and Lake Ontario lobes of the Laurentide ice sheet met, depositing billions of tons of sand and gravel into a meltwater channel. The elevated sandy ridge acts as a regional drainage divide, splitting water flow between Georgian Bay and Lake Ontario while supporting black oak savannas on its dry summits. Fact 35. The Goderich Salt Sinkhole. In the late 19th century, solution mining in Huron County demonstrated the instability of subterranean evaporite beds. Pumping fresh water into deep salt layers to extract brine hollowed out underground chambers. Without sufficient rock pillars, structural failure triggered subsidence, dropping topsoil and rail lines into a wide depression. Department of Mines engineers investigated the collapse, establishing regulations for solution mining to prevent catastrophic subsidence along the Lake Huron shore. Fact 34. The Holland Marsh Gas Phenomena. Stretching across York Region and Simcoe County, the Holland Marsh contains organic soils that periodically release combustible subterranean gas. Formed in an ancient glacial spillway, centuries of decaying vegetation produce trapped methane and phosphine gases beneath clay layers. When atmospheric pressure drops, these gases escape, occasionally igniting upon contact with air to create low-level lights over drainage canals. University of Guelph soil scientists documented how subsurface decomposition continuously alters atmospheric and soil chemistry. Fact 33. Flowerpot Island Reef Structures. Rising from Georgian Bay and Fathom 5 National Marine Park, Flowerpot Island stands as a coastal anomaly. While surrounding shoreline is flat limestone, two isolated sea stacks rise 12 meters above the waterline. These natural pillars consist of durable Silurian dolomite that resisted centuries of wave action, while softer surrounding rock eroded away. Parks Canada manages the island, where elevated rock platforms support cliff-dwelling plant communities that survived isolated since the retreat of the Laurentide ice sheet. Fact 32. The Matagami Formation Lignite Coal. Deep within the James Bay lowlands lies the Matagami Formation, containing brown coal deposits. Deposited during the early Cretaceous, vast coastal swamps accumulated thick layers of plant debris along river mouths. Subsequent burial compressed organic peat into soft lignite coal seams up to 15 meters thick. Geological Survey of Canada assessments confirm these remote deposits represent one of the few Cretaceous coal basins in eastern North America, remaining largely unmined due to lack of all-weather roads. Fact 31. The Red River Delta Oxbows. The lower Red River meanders across a flat glacial lakebed in southern Manitoba, leaving behind an intricate network of abandoned channels and oxbow lakes. Over thousands of years, spring flood surges forced the river to cut through soft alluvial banks, bypassing old bends to carve shorter routes toward Lake Winnipeg. These cutoffs fill with sediment and marsh vegetation, forming isolated wetland habitats across Lord Selkirk municipality. The Manitoba Geological Survey tracks these scars to model historical flood boundaries. Fact 30. The Vermilion River Formation bentonite clay. In southwestern Manitoba, near Morden, the Cretaceous Vermilion River Formation contains thick beds of bentonite clay derived from altered volcanic ash. 85 million years ago, volcanic eruptions in western mountain belts launched ash clouds across the western interior seaway. The ash settled into stagnant marine waters, converting into sodium bentonite. Quarried for industrial uses, these expanding clay beds create impermeable layers trapping perched water tables, feeding springs while creating slope instability along the Pembina Valley cliffs. But what happens when these ancient marine sediments conceal entirely different geological structures buried directly beneath human settlements? Fact 29. Lake Charlotte's Drowned Valley. In Halifax Regional Municipality, Lake Charlotte conceals a post-glacial landscape mapped using high-resolution multi-beam sonar. Hydrographic surveys by the Geological Survey of Canada revealed submerged river terraces, ancient shoreline escarpments, and flooded forest floors beneath 30 meters of water. Before sea levels rose following the melting of the Laurentian ice sheet 9,000 years ago, this basin formed a dry river valley connected to the Atlantic coast. Sonar profiles identified drowned delta deposits and organic silt beds documenting rapid post-glacial marine transgression across Atlantic Canada. Fact 28. Cedar Bog Artesian Seepage. Located within Birds Hill Provincial Park in Manitoba, a cold-water seepage wetland thrives due to pressurized groundwater. Hydrogeologists mapping the aquifer identified sand and gravel eskers deposited by glacial meltwater streams 12,000 years ago. Rainwater falling on elected sand ridges travels underground between impermeable glacial-marine clay strata, building hydraulic head. Where erosion cut through the clay cap, cold, mineral-rich groundwater forces its way to the surface at a constant 4 degrees Celsius. Isotope analysis confirms an underground residence time of over 50 years, nourishing orchid and cedar communities in a dry prairie climate. Fact 27. The Manitoba Escarpment Marine Beds. Along the Pembina River Valley, dark shales of the Pierre Shale Formation preserve remains of an ancient subtropical ocean. In 1988, Canadian Museum of Nature paleontologists excavated a complete fossilized mosasaur measuring 13 meters in length from an eroding cliff. Microfossil analysis of surrounding bentonite dated the site to 80 million years ago, proving an inland sea connected the Arctic Ocean to the Gulf of Mexico. Radiometric dating of volcanic ash established the evolutionary timeline for large marine reptiles in the western interior seaway. Fact 26. Essex Peninsula Localized Deluges. Southwestern Ontario holds a documented history of severe short-duration rainfall triggered by lake breeze convergence zones. Environment and Climate Change Canada climatologists analyzed radar data from July 1989, when a stationary convective system dumped over 220 millimeters of rain on Essex County within 5 hours. The flat glaciolacustrine plain, composed of heavy clay, could not absorb the volume, causing rapid overland sheet flooding across hundreds of square kilometers. Surface runoff studies confirmed the lack of topographic relief prevents natural drainage, forcing municipal engineers to construct artificial drainage canals. Fact 25. St. Maurice Valley Bog Iron. Near Trois-Rivières, Quebec, Les Forges du Saint-Maurice became Canada's first industrial ironworks in 1737 due to surface bog iron deposits. Chemical analysis showed iron dissolved from Laurentian shield granite was transported by groundwater into acidic swamp basins, where iron-oxidizing bacteria precipitated solid iron oxide nodules. Early French-Canadian ironmasters harvested soft ore directly from shallow marsh beds to cast cannons and stoves. 19th-century geological surveys confirmed these biological iron deposits regenerate slowly over decades, as long as local hydrology remains undisturbed. Fact 24. Prairie Mima Mounds. Across southern grasslands of Saskatchewan and Alberta, thousands of low, circular earthworks known as prairie mounds continue to challenge geomorphologists. Measuring up to 1 meter in height and 20 meters in diameter, these regular hummocks were mapped using airborne laser scanning. Soil core samples analyzed by the Geological Survey of Canada show the mound matrix consists of loose topsoil overlying tight glacial till. Hypotheses regarding their formation range from gopher burrowing and periglacial frost heaving to wind deflation during the hypsothermal warming period, leaving these landforms an open subject of active geomorphic debate. Fact 23. Roseau River Artesian Peat Mounds. In southeastern Manitoba, pressurized groundwater creates floating peat islands within the Roseau River Wildlife Management Area. Hydrogeological drilling confirmed artesian pressure forces water up through fractures in underlying limestone bedrock, penetrating thick clay beds. Over thousands of years, living sphagnum moss accumulated around these upwelling springs, forming raised peat domes hovering above waterlogged soil. Radiocarbon dating indicates continuous organic accumulation for 6,000 years, sustaining isolated cold-water ecosystems within a vast boreal parkland transition zone. Fact 22. North Saskatchewan River meanders. Extending across central Alberta, the North Saskatchewan River maintains a dynamic channel system mapped through decades of aerial photography. Historical air photos dating back to 1925 show the river continuously cutting new oxbow cutoffs, abandoning channel loops, and depositing gravel bars along its alluvial floodplain. University of Alberta fluvial geomorphologists measured gravel transport rates, demonstrating spring flood surges redistribute thousands of tons of sediment annually. This erosion cycle reshapes the river corridor, creating island habitats and exposing fresh geological sections along valley cliffs. Fact 21. The Deep Basin Gas Vault. Beneath the foothills of western Alberta and northeastern British Columbia lies the Deep Basin, an anomalous petroleum system where gas-saturated sandstones sit beneath water-bearing strata. Petroleum geologists analyzing drill core data in the late 1970s discovered tight, low-permeability Cretaceous sandstones trapped vast natural gas reserves down-dip from water-saturated rocks. Capillary forces within microscopic pores prevent water from displacing gas, defying traditional hydrobuoyancy models. Regional seismic surveys confirmed this inverted gas accumulation spans 26,000 square kilometers, forming one of Western Canada's largest unconventional gas reservoirs. Fact 20. Moncton Basin Salt Tectonics. Deep beneath southern New Brunswick, Jurassic and Mississippian salt beds of the Windsor Group generated complex subterranean structures. Airborne gravity and magnetic surveys conducted by the Natural Resources Energy and Development Department revealed massive halite pillars rising through thousands of meters of overlying sandstone. As ductile salt flowed under geostatic pressure, it warped rock strata upward, creating structural traps for petroleum and potash accumulation near Sussex. Diamond drill cores recovered from these salt structures confirmed continuous beds of high-grade sylvite, establishing Atlantic Canada's primary commercial potash extraction district. Fact 19. Joggins Fossil Cliffs. Along the shore of the Bay of Fundy in Nova Scotia, 30-meter-high coastal cliffs expose a complete Pennsylvanian tropical forest ecosystem. Record tidal fluctuations reaching up to 16 meters continuously erode the cliff face, uncovering fossilized tree trunks of Hylonomus lyelli, the earliest known reptile. In 1948, McGill University paleontologists identified fossilized lycopod trees standing upright in their original growth positions embedded within sandstone. Sedimentological analysis confirmed rapid flash flood mud deposits repeatedly buried ancient swamp forests 314 million years ago. But how do these ancient coastal deposits impact modern infrastructure built directly on top of them? Fact 18. Mount Cabot Iron Caprock. Rising over 600 meters above sea level in eastern Quebec, Mount Cabot forms a prominent structural high dictated by iron-rich strata. Formed during the Paleoproterozoic era nearly 2 billion years ago, heavy hematite and magnetite beds accumulated within the Labrador Trough. As regional river systems eroded softer surrounding shales over millions of years, these dense metallic layers resisted weathering, leaving elevated plateaus that dominate the local landscape. The Ministry of Natural Resources and Wildlife monitors these iron formations, which directly influence local soil acidity, vegetation distribution, and regional radio signal propagation across the North Shore. Fact 17. The Souris Collapse Sinkhole. In southern Manitoba, historical salt dissolution beneath glacial-lacustrine clays triggered sudden surface subsidence near Souris. Deep Devonian halite beds of the Prairie Evaporite Formation dissolved as circulating fresh water moved along regional fault lines, creating large subterranean caverns. When unsupported roof clay collapsed, a sinkhole measuring over 50 meters across opened in local agricultural land, swallowing topsoil and drainage infrastructure. Engineers from Manitoba Infrastructure routinely conduct ground-penetrating radar surveys across the corridor to monitor ongoing subterranean subsidence hazards along provincial highways. Fact 16. The Ottawa-Bonnechaire Graben Rift Structures. Running through eastern Ontario and western Quebec, the Ottawa-Bonnechaire Graben is an ancient continental rift valley formed 500 million years ago. As the North American craton stretched, long parallel fault lines dropped a central block of earth downward, creating a structural valley that today routes the Ottawa River. Seismic monitoring stations operated by Natural Resources Canada record minor intraplate earthquakes along these ancestral fault lines annually. The faulting pattern dictates bedrock depth across the National Capital Region, forcing foundation engineers to drive piling over 60 meters deep through sensitive Leda clay to reach solid bedrock. Fact 15. Magdalen Island's Salt Dome Seamounts. Rising from the floor of the Gulf of St. Lawrence, shallow waters surrounding the Magdalen Islands owe their bathymetry to underlying carboniferous salt structures. Deep subterranean pillars of Windsor Group halite pushed upward through heavier sedimentary layers, warping the seafloor into elevated underwater mounds. These shallow stone reefs provide critical hard-bottom habitats for Atlantic sea scallops and American lobsters. Fisheries and Oceans Canada maps these salt diapirs using high-resolution multi-beam bathymetry, establishing how subterranean salt movement directly supports the regional commercial fishing economy. Fact 14. Rockcliffe Formation Volcanic Ash Beds. Beneath Ottawa, thin layers of altered Ordovician volcanic ash interbedded in limestone create tight hydrogeological boundaries. Deposited 460 million years ago from distant volcanic eruptions along the Appalachian margin, the ash transformed into dense illite clay over time. City of Ottawa hydrogeologists mapped these impermeable layers during light rail tunnel excavations, noting the ash beds block vertical groundwater movement. This forces shallow groundwater to flow laterally, creating perched water tables that complicate basement construction and municipal utility installation across urban neighborhoods. Fact 13. Oromocto River Old-Growth Floodplains. In southern New Brunswick, the lower Oromocto River traverses a low-lying alluvial basin shaped by centuries of spring ice jams and flood deposition. Fine silt and organic matter carried by seasonal overflow events built nutrient-dense bottomland soils, supporting rare silver maple swamp forests. Environment and Climate Change Canada monitors the floodplain, which acts as a retention basin absorbing peak water volumes from the St. John River system. Ongoing deposition of fine mud continuously alters channel depth, requiring regular dredging at boat launches while protecting downstream communities from sudden flood surges. Fact 12. The Utica Shale Deep Gas Reserves. Buried 2,000 meters beneath the St. Lawrence lowlands of Quebec, the Middle Ordovician Utica Shale holds vast reserves of unconventional natural gas. Deposited in a deep foreland basin, the organic-rich black shale layer spans thousands of square kilometers between Montreal and Quebec City. Energy sector evaluations estimate the formation contains tens of trillions of cubic feet of natural gas, trapped within microporous rock matrices. Environmental studies conducted by the provincial government highlighted risks regarding hydraulic fracturing near regional freshwater aquifers, keeping commercial exploitation of this subterranean energy vault under ongoing regulatory debate. Fact 11. Caribou Deltaic Plain Sands. In central British Columbia, glacial meltwater streams emptying into ancient glacial Lake Fraser deposited thick beds of coarse sand and gravel across the Caribou region. Following the collapse of glacial ice dams 11,000 years ago, modern streams cut deep ravines through these loose deltaic sediments, creating steep, unstable sand bluffs along the Fraser River corridor. The Ministry of Transportation and Infrastructure continuously monitors these sandy slopes, where active groundwater seepage triggers frequent landslides that wash out railway lines and provincial highways. But what happens when a single historic event transforms an entire geographic feature into an industrial catalyst? Fact 10. Escarpment Edge Red Clay Ravines. Stretching across Grey and Simcoe counties, active stream erosion along the Niagara Escarpment exposes deep red clay ravines in the Queenston Formation. Rainwater runoff continuously carves steep channels through the forest, revealing iron-rich mudstone layers that oxidize into bright crimson hues. The Ontario Geological Survey tracks these active erosion zones, where high water tables and swelling clays create localized slope hazards along public trail corridors and municipal roadways. Fact 9. Blue Mountains Geothermal Spring Line. Deep along structural fracture zones of the Niagara Escarpment near Collingwood, thermal groundwater discharges into local stream networks. Rainwater falling on high upland plateaus percolates kilometers into the earth along deep fault lines, absorbing geothermal heat from underlying Precambrian basement rock. Hydraulic pressure forces warmed mineral water back to the surface at constant temperatures year-round. Hydrogeologists mapping the spring line confirmed that dissolved calcium and magnesium salts in the thermal outflow originate from deep Paleozoic limestone aquifers, maintaining rare ice-free microhabitats throughout Ontario winters. Fact 8. Bobcaygeon Formation Fossilized Oyster Reefs. Extending across Peterborough and Victoria counties, the Middle Ordovician Bobcaygeon Formation contains thick beds of fossilized marine life. Approximately 450 million years ago, shallow tropical seas covered central Ontario, supporting dense colonies of ancient brachiopods, bryozoans, and early mollusks. Over millions of years, these calcareous organisms accumulated into durable limestone ledges visible today along river cuts and road quarries. Early settlers quarried these fossil-dense beds to produce agricultural lime, neutralizing acidic shield soils along the southern boundary of the Canadian Shield. Fact 7. The Sandbanks Inland Sand Sanctuary. Located in Prince Edward County, the Sandbanks coastal dune system forms the largest freshwater Behemoth Barrier dune formation in the world. Deep, coarse sand deposits left by glacial meltwater rivers were reshaped by Lake Ontario wave action and prevailing winds into massive inland sandhills, rising up to 25 meters above the water. Groundwater sinks rapidly through porous sand dunes until it strikes underlying tight glacial clay, seeping out along dune bases to sustain rare wetland pans. Ontario Parks manages the site, where desert-like sand dunes sit directly adjacent to cold-water marsh ecosystems. Fact 6. The Whirlpool Sandstone Ancient Delta. Running beneath the Niagara region, the Silurian Whirlpool Formation represents a geological band of quartz sandstone formed 430 million years ago by an extensive river delta emptying into the Appalachian Basin. Consisting of exceptionally clean, well-sorted quartz grains, this durable sandstone unit resisted weathering while softer surrounding shales eroded away. The formation creates caprock for the Niagara Gorge Rapids and serves as a vital historical building stone quarried extensively for regional infrastructure projects. Fact 5. The Chatham-Kent Subterranean Dome. Beneath Kent and Lambton counties, a massive subterranean salt dome pushes through deep Devonian strata. Rising thousands of meters from underlying Silurian evaporite layers, the ascending halite cap forced overlying rock layers upward into an asymmetrical dome structure. Petro-Canada and Geological Survey of Canada seismic profiles confirmed localized faulting and upturned sandstone edges around the dome formed ideal structural traps that stored millions of barrels of crude oil, driving Canada's earliest commercial oil boom at Petrolia in 1858. Fact 4. Thames River Ice Age megafauna terraces. Along river terraces of Middlesex and Elgin counties lie extensive late Quaternary alluvial deposits containing fossilized remains of Ice Age megafauna. Between 10,000 and 12,000 years ago, retreating Laurentide ice sheets left broad meltwater valleys where mammoths, mastodons, and giant ground sloths grazed on cold steppe vegetation. Paleontologists from the Royal Ontario Museum periodically recover fossilized bones washed out from sandy terrace gravels following spring meltwater floods along the Thames River basin. Fact 3. The Salina Group subterranean salt sheet. Underlying virtually all of southwestern Ontario at depths ranging from 300 to 600 meters lies the Salina Formation, an evaporite layer hundreds of meters thick formed during the Silurian period as an isolated marine basin evaporated. Over millions of years, geostatic pressure squeezed ductile rock salt, causing it to flow underground and form salt pillows, anticlines, and vertical diapirs. Every commercial salt mine, brine field, and natural gas storage cavern in southwestern Ontario originates from this single ancient salt sheet buried beneath everyday farmlands. Fact 2. The Dundee Formation prehistoric marine shoreline. Stretching across Ontario from Lake Huron to Lake Erie, the Middle Devonian Dundee Formation marks an ancient marine shoreline deposited roughly 390 million years ago. Consisting of fossiliferous limestone and bituminized shale, the formation formed as an inland sea covered the region. Weathering of overlying glacial clays produces heavy, dark topsoil famous for agricultural productivity, while tight underlying limestone acts as a regional bedrock barrier governing groundwater flow and foundation engineering standards. Fact 1. The Oil Springs Petroleum Eruption. On January 16, 1862, Canada's first massive petroleum geyser erupted at Oil Springs in Lambton County, fundamentally altering North American energy history. Drilled into strata overlying a subterranean structural trap, the Shaw well struck a pressurized reservoir at a depth of 46 meters. The unrestrained well spewed over 3,000 barrels of crude oil per day into the surrounding creek before being capped. This historic event proved Paleozoic sedimentary basins beneath southern Ontario held commercial fossil fuel reserves, launching the modern industrial petroleum age in Canada decades before Western discoveries. What kept these massive structural anomalies obscured across southern Ontario for so long was not a lack of interest, but a limitation of scale. Early geologists mapped individual rock outcrops on foot, missing broader subsurface patterns that required airborne magnetics, seismic reflection, and satellite altimetry to finally see as a single continuous system. Much of the deep subsurface remains unresolved today, as ongoing groundwater modeling by Natural Resources Canada continuously adjusts the boundaries of subterranean aquifers, while active salt dissolution slowly alters foundation stability in ways engineers are only beginning to measure. The topographic map on the wall looks complete and static, but the compressed layers of salt, shale, and ancient seabed beneath it are constantly shifting under pressures set in motion hundreds of millions of years ago. Which geographic anomaly or hidden geological structure in your own province or territory has always struck you as odd? Mention it in the comments below and consider subscribing to join us for our next detailed investigation.